Um, Share. This is the attendance homework for this week. It is up on As You Learn, but sometimes like the exponents or the lower scripts don't always show up properly. So in case they don't, you can take a picture of this or rewatch the video or write them down. Um, but they are up there. And that's what we'll be covering this week. On As You Learn, I do have the problems we'll be covering up there. But again, I didn't type them because depending on your word, the exponents and stuff aren't going to work out. So I think it's better just to go to My Math Lab and open the e-text up. And these are the pages. And the formulas, 4.1 and 4.3 do not have a lot, but 4.2 has a lot of formulas. And so if you don't want to write them out, you can look at them there. I wanted to start with this homework assignment, or not homework, but it was attendance for Friday. A lot of people missed it. If we have x squared minus 36 equals 0, that's better. When you're solving it, one way of solving it, which most people did, was the square root method. So you add the 36 to the other side, and then you take the square root of both sides. But the problem with that is you have to remember when you take the square root of both sides, it leaves a positive and a negative answer. So it was positive and negative 6 because both of those squared give you a positive 36. Another way of solving it, we could have factored it because it's x squared and 6 squared and it's a subtraction. The formula is called the difference of squares, x minus 6 and x plus 6. So then when we set them equal to 0, we get the plus 6, but we also get the negative 6. So this is a great method, but be careful. Any questions on it? Okay. Section 4.1 covers the power function, and we did a little bit with the power function last class. Well, we had Desmos give us the equation for the power function. The formula for it is y equals ax to the, whoops, I keep doing that. The x is in the exponent. A does not have to be there. Sometimes there's a number, sometimes there isn't. But if you have a number to the variable, this is a power function or an exponential function. Because x is an exponent. I think your book mainly uses exponential. once we hit this section. What happens is it grows really fast. So if your b is greater than 1, it's going to increase and grow real fast. If b is between 0 and 1, it will decrease really fast and then taper off. As for our graphing more than that, we're going to use Desmos. So most of the graphing for this course is on Desmos or any graphing avenue, the calculator. Let me bring up the homework. So if we look at the first group, what they want is if it's an exponential function. Well, to be an exponential function, the x needs to be in the exponent. If we look at A's linear because x and y are to the first power. So that is just a straight line. B, the x is not in the exponent. This is a cubic function. It kind of looks like a snake. C, notice in C, x is in the exponent, so it's an exponential function. So this is an exponential function. And because 3 is greater than 1, it's a growth. D, again, x is in the exponent, so it is an exponential function, but 2/3 is between 0 and 1. So this exponential function is a decay. E to the x. E is just a number in your calculator, and it's where your ln button is. So wherever your ln button, you'll find e to the x. So if we brought it up and put 1 in the exponent so that it was just e, it's 2.7. It's just a number. Like pi is 3.14, e is 2.718. Just a number. So for e to the x would be exponential. And it would be a growth because e is 2.7. E is greater than 1. A lot of times when we're using e, some calculators might have the e here also. This is e to the first power. If you're plugging in values for the x, you want to use the one with your ln. And if we have this calculator, it's right there. E to the x, they're always with the natural log because these are inverse functions and these two are inverse functions. Any questions so far? Okay. For number 2, oh, I guess F. F is not exponential because the x is not in the exponent. X to the e is the same as x to the 2.1, whatever it was, 2.718. So this is not exponential. It's almost cubed, 2.7. Any questions so far? Okay, the next group just want us to say if it's exponential growth or decay. They're all exponential. Now, the things you need to be careful of. So 2.1 to the x, the 2 is greater than 1. That is a growth. And if we look at D, 0.8 is less than 1. It's between 0 and 1. It's a decay. But these other two, notice there's a negative in the exponent. So if we have y equals 3 to the negative 1.4x. Remember, a negative exponent, we could move the number to the denominator. So this would be the same as 1/3 to the 1.4x. So it's actually between 0 and 1. So you have to be careful with the negative in the exponent. It actually is a decay. What happens is you have this growth. It's going like this. That would be 3 to the 1.4, but then this negative flips it on the x-axis. Or y. No, this one will go on the y. When it's up with the x, it flips on the y. When it's out here, it flips down. Now, I wouldn't trick you on the test and throw that in there. I would either have it like this. I wouldn't put the negative in the exponent. I want to just make sure you know that if it's between 0 and 1, it's a decay. If it's not, if it's a greater than 1, it's a growth. Any questions so far? They have some graphs in here. Now for our course, we're just graphing with the calculator. Yes. Okay. So to graph these, for number 7, let's do the positive first so we could see what it looks like, and then we'll do the negative and see how it changes it. If we have y equals 5, now to do your exponent, you use a caret. The caret is where the 6 is, so shift and hit the 6 button, and it brings it up, and then we'll put an x. And there's our graph. Now if we do y equals 5 to the negative x, notice it flipped it on the y. Any questions on that part? Okay. If we get rid of the negative and then add 2, when you add or subtract outside, away from, not up with the x, but out below, it will move up or down the same as the sign. So if I have a +2, notice this moved up 2. If I put a -2, it moves down 2. So when you, and this works for your parabola, your straight line, your cubic function, your square root, the absolute value. So it's an important rule, especially if you're going further in math classes. But the minus moves it down 2. When it's inside, up with the x, Now to put it up with the x, you need to put it in parentheses. So if we had x plus 2, well, just like the x moves right and left, this will move right and left, but it moves opposite of the sign. So this was a plus 2, but notice it moved left 2. So when it's inside with the x, it moves right or left like the x, but opposite sign. So then if we make it a minus, it moved right 2. But is there any questions on the graph? Is everyone able to enter the graph? Any questions? Okay. Um, Notice that when my number changes, the value that has the x on it. The graphs are very similar. It's just that the higher this number is, like this one's a 5, it grew faster. The 3 grew a little slower than that one, and the 2 grew slower than that. So it's the same graph, it just grows a little faster. And notice they all cross this point, 0, 1. So if we were shifting, that's the point we would shift from. Any questions on that? Positive. Number 47. Now they do a little bit on this in this section, but then once we learn how to solve, we'll do more with it. It says the purchasing power, real value of money, decreases if inflation is present in the economy. Every year there's inflation. Sometimes it goes down, most of the time it goes up. Inflation is usually around 2% a year. This example is saying 5%. So it says, for example, the purchasing power of our dollars after T years is 5% inflation. And they give you the formula. P equals R times 0.95. T is time in years. And it's in dollars. So R is how much you have. We look at part A. What will be the purchasing power of $40,000 after 20 years? So we have $40,000, or maybe make 40,000 a year. We want to find out how much that would be 20 years from now, as long as inflation keeps going up by 5% each year. Now, when you plug that into your calculator, 40,000 around 40, 1, 2, 3, times 0.95, and then use a caret for the exponent, 20. depending on your calculator, 40,000 times 0.95, the carats right here, 20, and hit enter. So everyone getting $14,339 and some change. So if you are making $40,000 a year and do not receive any raises, or maybe it's your retirement and you receive $40,000 a year and they never give you a raise. In 20 years, that 40,000 buying power is only 14,000. So that means the stuff you bought with that 40,000, that's all that you can't buy it all. You can only buy 14,000 worth of items. So the value of the dollar has diminished. Any questions on that? Now, a lot of times, I know my dad had told me, because I do his taxes, that I'd get another form because his unemployment gave him a 3% increase, which I don't know how that's going to help because inflation was 7% this past year. But anyways, he got a 3% increase. So some things will, like retirements will, give you an increase. This one's saying, how does this affect people planning to retire at age 50? Well, if your retirement doesn't increase with inflation, then it's definitely going to hurt you. If it does give you inflation, or cost of living is usually what they call it, then you'd be okay. But in this case, it lost its value very quickly. Is there any questions on that? Is everyone okay plugging it in? Okay. Let's look at number 48. Just A. The other one, I don't want to just plug a bunch of form. We're going to learn how to solve it in the next section. If a retired couple has a fixed income of $60,000 a year, purchasing power, real value money, after T years of 5% inflation is given by this formula. So P equals, they're getting 60,000 a year. And I didn't put the variable because right here it's going to tell us it, but this would be a T. For the problem, part A, what's the purchasing power of their income after 4 years? T is in years. So we put the 4 here. You're getting 48,870. Now be careful, my labs might want the change, like this was 38 cents. So there's $60,000. In 4 years, they can only buy $48,800 worth of stuff. Because everything, well, not everything, but most things have gone up by 5%. Any questions on that? Okay, this is used a lot. There's actually an inflation calculator. So this is an inflation calculator. Now, if you use $100, because this would be your value. Now we want the value of $1. So if we put 100 in and we go with, let's go with 2020 to 2021. So $100 is worth $101.40. Now the reason I used 100 was because I can see the percent in there. That's a 1.4% increase. So from 2020 till that end of that year, inflation went up by 1.4%. Usually it's around 2%, but this kind of dropped a little bit when COVID was starting, everything closed. But notice what happened the following year. If we go from 2001 to 2021 and 2022, 7.48%, so 7.5%. It really jumped this past year. And if you didn't get a raise at all, you can't buy the same stuff you bought the year before. Because on average, everything went up 7.5%. Some things didn't. Gas skyrocketed, but then dropped back down. So, I mean, there's certain cases, but on average, everything went up 7.48%. Is there any questions on what that buying power means? I would not make you use the calculator. It's not part of our course, but I think it helps understand what they mean by buying power. Any questions? Okay. Formulas. The formulas are under chapter 4. Here they are. Key concepts and formulas. Open it up a little more. There we go. I wanted to shrink it, but for this one, we did 4.1. I gave you all of it. Here's the formula for an exponential function. B cannot be 1 because then 1 to any power is just 1. So it's just a horizontal line. That's why B cannot equal 1. When B is greater than 1, you have your growth. When B is, should say, oh, it's showing you all, this is nice because it's showing you all the little rules, the negative exponent. These formulas I'll explain in a minute. But this one you can go back and forth, and we'll use it to solve equations. When the base is 10, you don't have to show it. Your calculator uses a base 10. And so that's why it doesn't have a base in there. Now, some calculators may have the other formulas in there. TI-84 does somewhere, but I can't remember where. I think it's under math, but they show you a change of base in 4.3. It's right here. Now, these formulas you need to know. because we're going to use them a lot. Once we use them, you'll know most of them anyways. These first couple, 4, are not as important because as long as you know the 2 other formulas that we're going to use, you don't need these. But they're nice because they make you solve it quicker. So notice if the b's are the same, it just equals 1. So if we had the log of 7, log base 7 of 7, it's 1. Because that's your exponent. And actually, they should give property 3 first. They don't need this property. Because if you know this one, log base b of b to the x is x. Well, up here, the x is a 1. Anything in the exponent will be your answer because they're inverses. The log of 1, let me strike this one. The natural log of 1 are both 0. So this one here, property 2. The log of 1, no matter what the base is 0. The natural log of 1 is also 0. And e to the 1, e to the 0 is 1. Anything to the 0 power is 1. So anything to the 0 power is 1. B, it's hard to see it, it's so small. B, and then in the exponent is log of b x. You could think of these as canceling if you want, and it just leaves the x. If m equals n, then the log of b of m equals the log of b of n. Usually we go the other way. But if you have the same log on each side, just one log, you can drop it, m equals n. That's what this one's telling you. So you could take the log of both sides, or you could take it off. Then these next 2, they kind of look like distribution problems. When you are multiplying 2 things and taking the log of it, you can separate it by an addition. So multiplication becomes addition. When you're dividing, it becomes a subtraction, the top one minus the bottom one. And then another one we'll use a lot when the exponent is, when there is an exponent, you can bring it down. So if we were solving for 5 to the x, if we took the natural log of both sides, we could bring that x down and solve. And so we use that a lot. Now these all say log, but the rules for the natural log are exactly the same. So the natural log of m times n is the natural log of m plus the natural log of n. So they're the same rules, whether it's a log or a natural log. The difference between them, if we have the log base b of x equals y, we can rewrite that as an exponential. And that was actually on the one before at the bottom. Right here. I wrote it a little different. I used different variables, but to rewrite it, start with your base and loop around. B to the y equals x. And that works going back the other way. We use a this time. Start with the base and loop around. Log base a of x equals y. So you just do that little loop and then it's easy to memorize. And you can go either way. Most of the time we have a log and we're trying to get rid of it. But sometimes we want to write it the other way. The other one, didn't see it on here. When you have the natural log, it's the inverse with e. So you can think of these as canceling. And it leaves x equals e to the y. Likewise, if we have we can get rid of the exponential function by taking the natural log of both sides, because these will cancel. The natural log of y equals x. So if you have a natural log and you want to get rid of it, you can take it to the e power on both sides. If you have the e and you want to get rid of it, you take the natural log of both sides. And we'll be using that process to solve equations. Any questions on that part? Okay. So we said y, well, I don't know. Let's use log instead. So if we had y equals the log of x, when there's no base, it's a 10. And then if we loop around, 10 to the y equals x. If we graph these, you can see how they're inverses of each other. So y equals, oh, I hope they have the trig functions on here. Here they are. Okay, so if you click the function button and go down to log x, this is the log graph. Now if we graph 10 to the y equals x, oops. Yeah, you have to switch the variables. Notice that these, here, let me make it bigger so you can see it. Remember, when there's no base, it's a 10. So 10 to the x equals y. See how they reflect? Here, let me make the line. Y equals x. They reflect across the diagonal. That means they're inverses. So whenever you're finding the inverse of a function, if you graph both of them, they should reflect across it. Any questions so far? So to get to that log, you need your table. There it is. You need your table, you go to functions, and then go down until you get to calculus. So then we have the log, depending on if you need a base or base 10. We have the natural log and the exponential. Any questions? So then if we do the natural log one, we do the natural log of x, and then delete these two. Do y equals the exponential there we go. Notice they also flip on the axis because they're inverse functions of each other. Any questions so far? Your calculator only uses base 10 for the log. So if there's no base, it's automatically base 10. Now, if you need to use your calculator to solve for something, the formula is right here. So if we had log base 2 of 7 and we wanted to solve it, we need to change it to base 10 to use the calculator. So it would be the log, and of course you wouldn't have to show base 10. Now, to memorize it, it's the top, the higher value goes on top. I don't mean numerical, I mean that it's sitting higher than the 2. The 2 is lower. So we could find the log base 10 of 7 divided by the log base 10 of 2. It will give you the same exact answer. So when you have different bases and you need to plug them in, you need to use a change of base. And that's what this one is. Any questions? Okay. Let's try putting it in the calculator. Okay. No, if I wanted to find the answer for this, I would rewrite it first, and then I'd plug it into my calculator. The log is right here. So log 7, close the parenthesis, and then divide by log 2. So our answer is 2.8. Any questions on plugging it into the calculator? Okay. When you're trying to get to the problems, Like for 4.2, I clicked on 4.3 because 4.3 starts here. Here's 4.2's problems. So then it's easier to get across or get to them. Write the logarithmic equation in exponential form. So these ones you're just rewriting. We'll do a couple, but then we'll do more next class. So we have, I like to put the log first, log base 3 of x equals y, because then my loop works. So when they write it the opposite way, flip it. So we start with the base and we loop around. 3 to the y equals x. Any questions on that one? Oh, sorry. I meant to make it a little wider. Number 2, log base 5 of x equals 2 to the y. Start with the base and loop around. 5 to the 2y equals x. Now this one's a natural log. Remember, the natural log is inverses with the exponential function. So to get rid of the natural log, take both sides to the e power. So I don't want to put an equal sign. So then we have e to the y equals, these are inverses, so they cancel and leave 2x. Any questions on that? Okay, the last one, log negative x equals y. Well, when there's no base, it's base 10. And then start with the base and loop around. 10 to the y equals a negative x. Any questions on that? Now, seeing that negative in there, oh, they have it down here. You cannot take the log or natural log of a negative number or 0. So if we took the log of a negative 3, you're going to get an error in your calculator. So if we go log negative 3, the log has to be greater than 0. Same thing with natural log. So if we took here and put a 0, natural log is the same way. Natural log of 0. So you need to be careful of that. And a lot of times what happens is you're doing your homework like 10B and you get an error and it's like, wait a minute, why? I know I'm plugging it in right. Well, you can't take the log of a negative number, so that one has no solution. And they do plug those in there. So be careful of that. Any questions on anything? Positive.